we're now going to start talking about solving trigonomic equations. And these are going to be equations that have the trig functions in them, and we want to solve for x. So you'll notice this says find all solutions of, and then we're going to solve for equations here. So the first one we have here is sine of x equals square root of 3 over 2. Now, remember what it means to solve an equation. Here we want to find all values of x. Here there'll be angles that if you plug them in, sine of that angle is equal to square root of 3 over 2. Now, before we actually talk about finding the exact answers, let's look at a graph. So I'm going to put sine of x in my y1, and I'm going to make sure that I'm in radians, okay? And I'm going to hit zoom. There's one called zoom trig that will give us a nice picture of sine of x. Okay, now if you hit the window, you'll notice this is going from about negative 2 pi up to 2 pi. They're not quite there, but about negative 2 pi to 2 pi. Okay, now, and you know this will be a wave pattern that goes on in both directions. Let's put the right-hand side of this equation, square root of 3 over 2. Now this will just be a horizontal line. And if you remember, the solutions here are going to be every place this horizontal line intersects our graph. And since this wave pattern goes on and this horizontal line goes on in both directions, we'll actually have infinitely many solutions. Now, just to kind of show you what's going on, I want to zoom in close here. So there's our sine curve going up. And there's our square root of 3 over 2. We actually see that it hits in 2 spots. Okay? Now, we can use our unit circle. So I'm going to pull up our unit circle to find where this happens. Might be hard for me to get it big, but remember the sine value is the y value. So we're first going to look at the unit circle and say, where is the y value equal to square root of 3 over 2? And we see that that happens at 60 degrees or pi over 3 and at 2 pi over 3 or 120 degrees. Okay, so we could do this in radians or degrees. So in radians, we saw that it was pi over 3 and 2 pi over 3, which would be 60 degrees or 120. Now remember, any angle that is coterminal, right? We have infinitely many solutions. We talked about how it's going to intersect twice, really, anytime we go up here in the first quadrant of our unit circle, or first hemisphere. So we're saying any angle that's coterminal to pi over 6 or 2 pi over 3 would have the same sine value. So we're saying anytime we go around that circle again. Now the way we write this out is we say plus 2 pi k, and we'll write a little note where k is any integer. So we're saying if you add or subtract any multiple of 2 pi, go around the circle, you would also get another angle that satisfies this equation. Now with the degrees, instead of saying 2 pi k, we would say 360 degrees k. So we get our angles the first time around the circle by looking at the unit circle. And for most of these, if you just have a simple equation, you'll have 2 of them, unless it's a quadrantal spot. And then if we're asked for all solutions, we're going to add this 2 pi k if it's in radians and 360 k if it's in degrees. Okay, so let's think about the next one. The next one we want to know, where's cosine of x equal to negative 1/2? And we could very similarly look at a graph. So there's our cosine of x. And there's our line, and we see really kind of every period of it, it's going to intersect twice. Okay, so on the unit circle, we want to look where is the x equal to -1/2. So we see that happens at 2 pi over 3 and at 4 pi over 3. Which in degrees would be 120 degrees and 240 degrees. And since we're asked for all solutions, we'd say plus 2 pi k plus 2 pi k, or plus 360k. Okay, next we want to look where is tangent of x equal to the square root of 3. So let's actually put in tangent of x and the square root of 3. Now, this calculator kind of draws in those asymptotes. Those vertical lines aren't actually part of the graph. So we see we have one spot kind of every pi, okay, where the graph hits it. So remember the period of tangent is only pi instead of 2 pi. So we're going to look and say, okay, where is y over x equal to square root of 3? And this is where, so here at pi over 3, if we took square root of 3 over 2 over 1/2, we'd see these 2's cancel out and we would just get square root of 3. So it's where you have square root of 3 over 2 in the y coordinate and 1/2 in the x coordinate. So here at 60 degrees, or pi over 3, okay, now if they were both negative, if we had negative square root of 3 over 2 and square root of 3 over, and negative 1/2, those negatives cancel out and we would also get square root of 3. So that happens at 4 pi over 3, or 240 degrees. And notice there's something really special here, and it comes down to tangent having a period of pi. These happen exactly 180 degrees from each other, exactly half the circle. So instead of saying we need both of these in every multiple of 360, we could actually just write the pi over 3 and say if we add any multiple of 180 or any multiple of pi halfway around the circle, we would get all of them. So we actually won't need to write this second set this time, but instead of saying 2 pi k, we'll just say pi k. And we'll just say 180 degrees times k. So if your solutions are exactly 180 degrees, exactly opposite on the unit circle, you actually only need to write one of them. Okay, let's look at one more example here. We have 4 sine of x minus 1 is equal to 2 sine of x. Now before we actually are going to be able to solve this, we need to get it into the form sine of x equals something. So I'm going to subtract 2 sine of x from both sides. So I'll have 2 sine of x minus 1 equals 0. So 2 sine of x equals 1. So sine of x equals 1/2. So we want to know where's the y coordinate equal to 1/2. So that happens at 30 degrees, pi over 6, and at 5 pi over 6. So that would be at 30 degrees or 150 degrees. Okay, and since these aren't directly across the circle from each other, we would have to use both of them and say plus 2 pi k or plus 360 degrees. Now oftentimes you'll only either be asked for the radians or the degrees, but I showed you both here so that you get practice finding them.